Okay, so now that we've finished our unit on linear equations, we're going to still use those skills into our next topic. This is called systems of equations. So what exactly is a system of equations? Well, a system, so we get that point, is just two or more linear equations, okay? So right now we're going to deal with linear, but a system is just two or more equations. You could see quadratics and linear, so that's going to come down the road. But for now, we can find the solution to the system, meaning there is a solution to the two equations. The solution is the point where they touch or intersect. So I would write the point x comma y where the lines intersect, but then I would also put in parentheses the solution is where they touch. That's important to know because there are three types of solutions. Just like there's three types of solutions when we solve an equation, there are three types of solutions when we solve systems of equations. So the first type of solution we'll look here is one solution. That is when we have intersecting lines. So if you draw this line and you draw the other line, you see the two lines I'm referring to? They touch in one point. So that exact point is the solution. So when we're trying to find the solution to this, we would state that point. The second type is a no solution. Think about what we wrote on the last slide. We said the solution to a system is the point where they touch. Well, if they never touch, there is no solution. So when you look at these two lines, the yellow and the purple, they never intersect. So if you have parallel lines, the answer is no solution. Our third type is infinitely many, okay? So infinitely many is when you end up graphing identical lines, because if I graphed one line, the other line goes right on top of it. The same line is going to touch everywhere. So there are infinitely many solutions. So let's go see what this looks like. In order to solve systems by graphing, so for now we're just going to solve a system by graphing. I need to make sure my equations are in slope-intercept form. So please write must be in y equals mx plus b. So if I look at number 1, both of my equations are in that form already. So I can take my first equation, I can find my m, and I can find my b. Remember, my b is where I begin, so I put a point at -8. I'm then going to do my slope, up 1, right 1, because it's a positive positive. I'm going to do that again. Now, typically we have said 3 points. The dilemma is you might need more than 3 this time so that your lines touch. So what I would do is I would do 4, maybe 5, okay? And draw your line. Then we're going to draw our next line. So I'm going to write my slope is -2/1, my y-intercept is 1. Put a point at +1, and I'm going to go down to right 1, because I went down because my rise was a negative. I'm going to do that again. Now, I need to be precise. You need to see the exact points. So I need to do it again. Notice right there, my lines intersect. So it's this point here in blue. I have to figure out its ordered pair. It would be 3, -5. And that is the answer. 3, -5 is your solution. You cannot just say one solution. You actually have to state the solution, okay? Now, how could I check to see that I was correct? Well, I would take my ordered pair and I would then plug it into the actual equation. So if you took this ordered pair here and you replace into this equation, I would replace my x with 3 and my y with 5. If I get -5 equals -5, it worked. but you also have to plug it in here to see that that works. And so you know it does. But that's how we can check, is our solution correct? Okay? So let's go look at my next one. Same thing, okay? I am going to identify my slope and my y-intercept. Okay, I plot my point at 9. Now, look at my slope. I can go up 1, right 2. Technically, I could put my line now, but I need some more points. So what I'm going to do, I need to have positives, meaning I can now go down and left, because a negative and a negative give me a positive. And I can go down and left again. So draw your line. I like to start with 4 points, okay? So our next one, my slope here is -1 over 1, and my y-intercept is a positive 6. So I'm going to put a positive 6. I'm going to go down 1, right 1. But I notice if I kept going down and right, I'm not going to hit my line. So instead, I'm going to go up and left. That still gives me a negative. And then I'm going to go up and left again. Look at that. My 2 lines will touch at exactly 1 point. So I just have to figure out that point. Well, if I count over -2 and I count up 8. I want you to write in, check your solution by plugging in to both equations. You need to have that. So the first step on our last slide said to make sure your equations in y equals mx plus b. So if I look at both of these, it's not. So what I have to do is I have to solve for y. So I'm going to start with my first one. I'm going to add 3x to both sides so that I get y equals 3x plus 8. I can identify my slope and I can identify my y-intercept. And then I'm going to graph it. So I can't go up 3, but I can go down 3 and left, and then down 3 and left, and there's my line. It's a little off, but here's what I need you to realize. Your slope is positive. So you need to make sure that you went the right direction and the line you drew has a positive slope, and it does. So then I'm going to do my next one, I'm sorry. So I need to isolate for y. So I'm going to add x to both sides. I get y equals x minus 2. So my slope is 1 over 1, and my b is -2. I'm going to place a point. Watch what happens. If I go up and right, and I keep doing that, I'm never going to reach the other line. You see? So this time I need to actually go down and left, and down and left, and down and left, and yet again. Now make sure you're right and draw some other points, okay? But connect it on this line. Keep going. Extend the points to make sure you were right. If you notice, there is that point where they touch. So you have to find that exact point. Just keep going with your slope. It's not always going to be there from the get-go. So the point where those two touch is -5, -7. It is very important that you plug this back in to both equations to check. That needs to be written somewhere on your notes. Plug solution back into both equations. So let's do one more together because this one's a little different. Again, one of them's in slope-intercept form, one of them is not. So I'm going to take the one that's in standard form and solve for y, okay? So that I get 2y equals -x plus 4. I'm going to divide everything here, everything, by 2. So what happens is I get y equals -1/2 x plus 2. Ladies and gentlemen, if this is too fast, you have the ability to pause. But you need to be understanding how we're getting these equations. So I can identify my slope is -1/2 and my y-intercept is 2. So I place a point at B at 2. Then I'm going to go down 1, right 2, down 1, right 2, and down 1, right 2, and I can draw my line. Let's go look at my next equation. My slope is -1/2, and my y-intercept is 2. Well, I'd have another point, down 1, right 2, down 1, right 2, down 1, right 2. Well, look at those two lines, ladies and gentlemen. It ended up graphing the same line. You did not know that from the given problem. But what happens is when you graph the same line, you have infinitely many solutions, okay? Meaning, pick any point on that line, but the point has to be on that line. Plug it into both, and if it works, try another one. What a lot of us don't do is plug the points back in to check, okay? So I know this kind of went quickly, but it's review. All you're doing is you're graphing two equations and you're finding the point that they touch. If they don't touch, it's no solution. If they touch in one point, it's that point. And if they are the same line, it's infinitely many. So try these two on your own. We're going to be looking for them, okay? And don't panic. This is just the start of the chapter, and we are going to practice this. What you need to know from today is that a system of equations is two or more equations, and their solution is the point where they touch.